Okay, good. Sorry about that. My laptop crashed. Mac OS. So this talk is called Everything in Elm. And the title on the web page is Everything in Elm. But in actuality, it's more like Everything in Elm, ... So just to get a general idea of what you guys already understand, how many people know what a native module in Elm is? Okay, and put your hands up if you know that you shouldn't use them. Okay, okay. So for those who don't know what a native module in Elm is, basically Elm, the core libraries, the underlying implementation of Elm is written in JavaScript. And right now, we generally refer to that JavaScript as native Elm. It's basically like handwritten compiled Elm. And it allows you to do like all kinds of funky things because it's just JavaScript. You'll see why this is relevant later on. So a bit about me. My name is Noah Hall, also EUE56. I'm this pink blob ET thing on Slack. And I'm going to show you some examples of things that people consider hard to do in Elm and how they're not so hard, actually. And then also talk about some things that you can do in Elm, but you probably shouldn't, and some things that you probably should do in Elm. So first of all, my personal motto is, if it makes sense to do it in Elm, we can do it in Elm. I like to believe that there's not anything you couldn't do in Elm, and that if you feel like there is, then tell me, because I will probably try and do it. But at the same time, I also am a strong believer of not compromising the Elm experience. So there might be some things that you do in Elm that you shouldn't do in Elm, and that's because they compromise how Elm works or how Elm feels, or it's basically just changing how Elm interacts with anything else. So some expectations, that looks a lot like exceptions. So I have to remember it's not exceptions. The letters are in a different order. So some expectations that we generally have from our Elm code is no runtime exceptions, no side effects without commands or tasks, and a really nice time. So we're going to try and uphold those three rules. We'll see why. So I'm guessing if you're here, then you've probably seen the OsloElmDay site. Right now, all of it is in Elm, pure Elm except for some exceptions, which we'll talk about in a minute. And that includes the SVG thing you see here, moving along. So this animation is done entirely in Elm. The code for it is pretty simple. It was just SVG elements, which have been translated by a certain amount, and then we hook it up to something called animation frame to keep the browser in sync with the rendering speed so it's smooth animation. If you've done animation before, you know about that. So, yeah. And in Elm, that's basically all it looks like. We have a view function for our different shapes. This is a triangle one. I've cut out a whole bunch of boilerplate. But the view triangle is basically just given the triangle, you figure out the points of the triangle, and then you draw it as SVG onto the SVG thing you're making. And then you also have a subscription to the animation frame so that you stay in sync, like I said. So the exception on this page that I talked about, where something isn't written in just Elm, is if you hover over this button, you get a little firework. And if you hover over this, then you get a little ease in, and I don't know what to call that for a button, but like slow highlighting. The reason why that's not in Elm is because generally animation things like that are quite hard because they rely on the local state of the DOM. Whereas in Elm, we just have a fixed DOM, and we try and work with it. So what we did, or what Ingo did, who wrote this in Elm, was we use the library called bodymoving.js or something like that, which basically allows you to look for certain elements and attach an animation to that element. So you can see here that we have a class, two classes. One is animate, and one is animate-fixed. We have a third one, which is, well, we have 4 technically, but 3 we care about. And the third one is ticket button with an underscore. And what we do is that when our Elm application starts up, we send out a message to report saying, hey, Elm has rendered now, so go attach things, go do things to us. So we have a subscription to the initial event, basically, that's triggered from inside Elm. And we then grab the ticket button and attach the body moving animation to that element. And that's super simple. Like, it works. It's pretty reliable. It's easy. So doing everything in pure Elm, like that example, is not always a good idea. Animation, if you are trying to do in pure Elm without a library like body moving, or some JavaScript library that attached to the DOM, you end up trying to compensate for a whole bunch of the calculations that you can do in JavaScript, because JavaScript can work after you have rendered an element. Whereas in Elm, everything happens before you render an element. Not everything, but mostly everything. And anytime that you want to do an animation on a model, it can be quite slow to send stuff into the model and create a new model and then render a new view and keep doing that for every millisecond. You don't necessarily want to do that. So this is one particular case where I think you probably shouldn't be writing animations like that in Elm. The SVG one is fine, because it doesn't necessarily work in the same way, but one which requires like the height and width and position of the element, and to modify a property of the element slowly over a certain amount of time, probably better in JavaScript. So next, who's heard of doc tests? Some people. Who's heard of Elm doc test? Less people. OK, to be expected. So a doc test basically means that you can write some documentation as if it's an example. So you see here, we have some documentation which is adds two numbers together for this crazy simple function. And then we have two examples of how it works. So we have an example of adding 0 to 3, and we have an example of adding -6 to 9, and we have both results being 3. So Elm doc test is a tool that will go through the comments and actually pull these out and generate a test suite based on that. So you can see here that the example is used alongside the expected value to generate or test for that particular function. So I'm going to talk about how this is implemented. So Elm doc test is a command line tool. It is given a bunch of files, and it will go through and process those files, and it will pull everything out and then create new files. Now, in Elm, you can't do any file I/O because there isn't a wrapper for that. There are ways of making your own wrapper, but in Elm doc test, the approach that was taken is to keep as much Elm inside Elm as possible, and only do the side effect for I/O through ports. So, for example, we have a read file port that when we get a file name, we're going to read that file in JS and then send the data from that back into Elm. And then later on, we're going to send out of Elm something to say, write a file. So here's what it looks like in Elm. The read file, you just send a file name with it, and it will open the file in JavaScript. Write file, file name and text, pretty simple. And generate module doc test. Basically what that does is just parse through the text that you give it and send out the right command at the end. So generally, if you're going to make a command line tool, it's a pretty neat way right now to just use ports for doing I/O operations. So if you have something that you want to write and you don't necessarily, and you need some node functions or some node supports, you can really, really easily just use ports, just like that example, and have all the actual logic for doing all the hard work inside Elm. And that's generally what we care most about when writing a tool like this. One benefit of that is that the core logic, the Elm part of that, can actually be published on package.elmlang. So if we wanted to use it in, say, a browser or part of our site, then we could just use the same core logic and not care about where we get the text from. So that's nice. So this is JSON to Elm. JSON to Elm is a tool that will take some JSON. Oops, my keyboard layout's changed. And it will parse that JSON and then generate some code based on that JSON. It doesn't have to be code that looks like this. You can actually change which package it uses, or even change it into English, so that down here we say, OK, create something of the type something. It must have a field called hello with the type int. And the way this is represented internally is through using an AST. If you haven't heard of that before, then an AST is just a way of representing some code or some data, usually recursively. So you can see here that we list all the possible known types that we might have from a JSON blob. For example, a maybe. So if we had something that could be a null or could be 5, then we can say that is a maybe int. So that would be a maybe type of int type. And this way allows us to really represent at a really, really high level of what the code is actually doing. So we can also put in here type aliases like this. Like that. And it will parse the type alias, so it will parse the Elm code that you give it and turn it into the same single AST. So this code, this AST here, is representing both ways. They both get parsed and put into this. And here's an example of turning that AST into the English. So if you have something that's unknown, the English for that is I don't know what it is. If you have something that's complex, the English for that is something that you have to write. If it's an int, for example, then you can say, I got an int value, and so on and so forth. And the functions for turning that AST into something else look extremely similar for the other, for generating the decoders. So if we weren't generating English and we were just generating the decoder, then the code looks very similar to this. Well, there it is. You basically just have a function which will take a string and generate the decode bit. So this bit here is generated by this function. So again, what we're doing here is reading text in. We're putting it into an AST, and then we're generating code from that, or English. And all of this can be kind of agnostic to the tool, to the browser, or the command line, just as Elm doc test could be. So you could write your own ports that would read up a file and send that into Elm. And you can actually publish this stuff onto package.elmlang so other people can make tools with what you made. And that's a really, really nice thing. So one other thing is called Elm Serverside Renderer. Do I have too many? It's render error. Yeah, it's not meant to be that. So what this does is allow you to, my keyboard layout is strange, pass in HTML nodes that you make with Elm and converts those to a string. So if I gave it something like this, then it would generate it as you would expect. And the way that works is very similar. We have an AST, which says these are the possible nodes that you might have inside an Elm application. There's 5 here. This actually matches the Elmlang virtual DOM. And we have a decoder, which will take, this is an example decoder for one of these cases, which is the node entry. So those are your generic nodes like div or li. And each one of those has a tag, which would be div in the case of div, the children, any children elements, facts, so that would be like attributes, and descendants counts is something that's used by the virtual DOM to figure out where to go. And so this is a slightly different approach to the other 2 examples in that for this, I use some native code. So inside your Elm code, you can't send any old thing outside of a port. So if you're sending things out to JavaScript, then it needs to be a certain set of types or a JSON.value. But what we actually want to do is grab the actual underlying representation of how HTML is represented. So what we do is define this function, which is called native server-side renderers, server-side helpers.stringify, which basically just takes a HTML thing. Here it takes A. It shouldn't take A, it should just take HTML. And it returns a string version of that using JSON.stringify, which you can then feed into your decoders. And that's interesting, but it's also kind of bad, because now we can no longer publish this. Like, nobody could use this. And for about a year, maybe a bit longer, this ability has existed inside Elm, but nobody would be able to use it because there's no way to actually install it. Like, you could see it on GitHub, but there's no way to install it. And so what I actually did was split all the logic out, as with doc tests and JSON to Elm, and then it could be published, and now it can be used by several different projects. So for example, if you're using Elm HTML Test, oh, thank you for putting a link there, then you can, then what this does is use that AST to go through and find various things based on what you're looking for. So for example, if you're searching for a button with the tag button, then we will use the tag information that we get from Elm to figure out where that is. Elm HTML Test actually does have some magic way of doing that, but that's not important. And it's also used for a static site generator. So that's a cool thing. So native code is extremely helpful for debugging and tools, but every single line that you add is another line that you can mess up. So every time you add one line of JavaScript inside your native Elm project, then there's an increased chance that you can actually just break your entire application. And here's an example. So what we're going to show is that this little text box here, when I type in it, it triggers this update function. And all this function is doing is actually just returning what I type, but it's also calling a function called regex.regex. And what regex.regex does is create a reg exp in JavaScript, using the text that you give it. And so if I make an invalid character set, suddenly it doesn't show up anymore. And if I reload, just to show that it was working past 4 characters in the first place, then it does. But if I do plus, 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 then it doesn't do anything. And if I turn on errors, then you will see why. We got this error, which is a runtime error in Elm, which crashed our entire application, which meant that we couldn't do anything. And that's not really a very good thing. I mean, it's not. There's no way to recover from this. There's no way to restart your Elm application. Thankfully, this is one of the, I think there's 6 now. There's 6 possible ways of introducing a runtime error using code that you can install from package.elmlang. This is one of them, and it's going to be fixed in the next version, which is good. So in practice, this never, ever happens to anyone. But if you are writing your own native code, then it might happen. So some things to think about. Generally, any problem is solvable in Elm. Or I say generally, any problem is solvable in Elm. But sometimes you shouldn't solve it in only Elm. You can use ports really easily to just send things out and trigger some JavaScript thing to do something. And that's the best way to really kind of work with any kind of tricky situation where you might need animation, or you might need access to the DOM, or you might need to read a file from a node, or you might need to, I don't know, do lots of things. But generally, ports should be the first thing you reach. So reach for. So hopefully, now, next time when someone asks, should you use native, nobody will put their hands up, and yeah. And then also as a kind of semi-related thing, modeling problems as an AST means you can generate differently shaped code. And when you combine that with ports, you can publish your AST, and it can be reused by different packages to do entirely different concepts and entirely different things and entirely different ways. Just like JSON to Elm can be run on a command line, or it can be run in a web page. And one final thing, join the Elm Slack. If you're not already on there, we have 2 channels that you can join just for us. By us, I mean Norwegians, which might not be all of us. But you can join all of them anyway. So there's OsloElmDay, and there's also #Norway, which isn't hashtag. But all questions and any question that you have about anything, including native code, will be answered. Any kind of tricky situation with animation or anything else like that that you get stuck on, they will be answered. And that's it, and that's me. Thank you.